How do we calculate angles using dot products? Well, remember that there are two definitions of dot product. We're multiplying the parallel components. We can multiply that out by multiplying the x components, multiplying the y components, and then adding them together. Or we can take the magnitude of v times the magnitude of w times the cosine of the angle between them. If we combine these two ideas, we can take this and substitute it in and get that the product of the magnitudes times cosine theta, so this equals the sum of the products of the components. We can divide by the magnitudes. On both sides. And then we will get cosine theta equals that. So in other words, theta equals the arc cosine of that whole thing, which I have on this next slide. Theta equals arc cosine of the dot product of v and w over the magnitude of v times the magnitude of w. A lot of people, actually I would say most people, rewrite this as arc cosine of v dot w over the magnitude of v times the magnitude of w. So that's something that you should have in your notes. Theta equals this formula. So let's do some examples. Find the angle between these two vectors. So if I have those two vectors, what I'm going to do is I'm going to take arc cosine of, let's see, I'm going to write it out the long way, 1, 2, dotted with 4, 7. And then I'm going to take the magnitude of 1, 2 times the magnitude of 4, 7. So this whole thing will become, well, we multiply the x components, multiply the y components. In the denominator, we'll write 1 squared plus 2 squared and 4 squared plus 7 squared. So we have 18 over square root of 5, and that is square root of 16 plus that's 65. So let me grab my calculator. When I type that into a calculator, 18 divided by square root of 5 times square root of 65. So 18 divided by arc cosine of 0.998. So I'm going to do arc cosine of that, which gives me approximately 3 degrees. Let's do another. So arc cosine of the dot product divided by the magnitude of the first one times the magnitude of the second one. Multiply the x components, multiply the y components. We have 9 plus 4 and 4 plus 49. Did I do that correctly? No, negative 2 times negative 7 is positive 14. And then we get 8 over square root of 13 times square root of 53. So 8 divided by square root of 13 times the square root of 53 gives us arc cosine of approximately 0.305. And when we take the arc cosine, we get approximately 72 degrees. Now this becomes useful in certain special cases. So this one is going to be a particular answer. I chose this example specifically to illustrate a point. All of these are finding angles between vectors. So this is 10 squared plus 45 squared, and 2 squared plus 9 squared. So the numerator is 20 plus 405. The denominator is square root of, 100 plus 45 squared is 2,125. And then this is 4 plus 81, so 85. When we combine the numerators, the parts of the numerator, we get 425. When we combine the parts of the denominator, we also get 425. So this is arc cosine of 1. Ooh, arc cosine of 1, you should know that immediately. It's 0. These are parallel vectors. We have 10, 45, and then it's parallel with 2, 9. So this is a way of telling that vectors are parallel. Let's look at these two. We're taking arc cosine of the dot product over the product of the magnitudes. So the product of the magnitudes, we have square root of 1 squared plus 3 squared, square root of 6 squared plus 2 squared. I'm ignoring the negatives because remember when we square a negative, it always becomes positive. 1 times negative 6 is negative 6. 3 times 2 is positive 6. We have square root of 10 and square root of 40. The numerator becomes 0, so the whole thing becomes 0. And arc cosine of 0, you should know, is 90 degrees. So this is a way of showing that two vectors are perpendicular. And that's how we find angles using dot products.